Alright, gang, this video obviously pertains to the handout called More on Summation. This is something that I might have included directly after 5.1, or it's possible that I waited until after 5.3 to kind of take a look at this, because this is kind of as far as like our test goes, this is kind of an above and beyond topic that currently in my pre-calc class I involve as like a bonus point opportunity. So here we go, more on summation. I'm going to be doing this maybe a little out of order, so just bear with me. What we're going to be looking at is sums like this. So given to you in this sigma notation, this sigma shorthand. So we're adding up from I equals 1 to I equals 76. The series, the sequence slash series given by that. So something I'll point out right away, which is going to hold true throughout this whole activity, is that this sequence slash series, this is definitely not going to be arithmetic in nature, nor will it be geometric. So especially if we're looking at this, you're watching this video after we've gone through, not just section 5.1, but also 5.2 and 5.3. That should ring true with you. You should understand what I mean by, if you start writing out this sequence, plug in 1 for I, and then plug in 2 for I, and then plug in to get the third term, and plug in 4 for I to get the fourth term. It is not going to turn out to be arithmetic nor geometric. So those very specific formulas that you can use, remember there's a formula to find the sum of an arithmetic series, and there's another specific formula to do a geometric sum. So those two, neither of those two formulas are going to apply here, because again, not arithmetic, not geometric. So here's what we're going to do. Oh, and also, by the way, just really quick, since we're going from 1 to 76, man, I don't think you're going to want to add this up by hand. Literally figure out all 76 terms and then add them up manually. I don't think that's what you're going to want to do. So there's got to be another way. And here's what we're going to do. We're going to apply those properties that we learned in 5.1. Just those very simple basic properties where you can, first of all, split this up into different, separate sigma definitions. So all these terms, like this term and this term and this term and this term, you could break it all up into separate sigmas, like separate sums. So that was one of the properties of sigma, And then the other major property was that, if you had something like 2i squared or 4i, you could bring those coefficients out in front of the sigma. So this 2 could come out in front if you wanted to, or the 4 could come out in front. So we're going to apply those properties, break it up into separate sigmas, and then bring any coefficient out in front. And something that I might follow up on later or refer back to later is that technically you could say, oh, let's bring this 9 out in front and leave this as sigma 1. That's possible. So I just wanted to mention that really quick. And but what do we do next? We still have to do like sigma I cubed from 1 to 76. We still have to figure out what sigma I squared is from 1 to 76 and yada, yada, yada. So that's where we now refer back to the formulas that exist. And what we should have already seen was at least one of these formulas, this one, where it was really just like sigma from 1 to whatever of just a constant, like sigma 7 or sigma 12, right? We've already written down and kind of worked with this kind of situation and that formula. So do you remember what this formula is if we're just going from 1 to whatever and that c-val is just a number? Do you remember what the formula is? It's that. So we can do just whatever that number is times, again, for example, like if we were doing sigma 12 from 1 to 99, you wouldn't have to do like 12 plus 12 plus 12 plus 12 plus 12 plus 12, like 99 times. You can just simply do 12 times 99. And like I just mentioned a minute ago about, well, technically you could bring the 9 out in front and leave it as sigma 1. Heck, wrong way. We could also sort of think of there being, we could even go one step further in a way and say there's a formula for sigma 1, right? Sigma 1 from 1 to 99 or from 1 to 50 or whatever. I mean, that would still follow this green formula, but that would just simply then be n. Okay? I mean, right? If we're just doing, like if we were doing from like 1 to 50, we would just do like 1 plus 1 plus 1 plus 1 plus 1 plus 1, and 50 times, right? So that's that formula, which should already be somewhat familiar to you. But there's other formulas that you've probably never seen before. So there is a formula, first of all, for sigma I. So what that means is if we're going from 1 to whatever, let's say we're going from 1 to 50, that would mean 1 plus 2 plus 3 plus 4 plus 5 all the way until 50. But, the good news is that this formula doesn't just hold true from 1 to 50, like it's literally anything. If we're going from 1 to 99 or 1 to 500, this formula where whatever this number is, whether it's 50 or 99 or 75, that's just going to plug in for n. And that will be the sum. So, 1 plus 2 plus 3 plus 4 plus 5, as far as you want to take that, all the way to n, that's the formula which will give you the sum for free. Likewise, we're going to have a sum for sigma I squared. That means it's 1 squared plus 2 squared plus 3 squared plus 4 squared plus dot dot dot. You go as far as you want to, whether it's 1 to 10 or from 1 to 99, doesn't matter. Like whatever that n is, you plug it in for n, these n's, and it will tell you the sum of the first whatever perfect squares. That's another way to say that's what this is doing. It's a formula for the sum of the first n number of perfect squares. Just like you could say this formula is for the sum of the first n number of positive integers. And then same with this last one. There's a formula that'll give you the sum of the first whatever number of perfect cubes, like 1 cubed plus 2 cubed plus 3 cubed plus 4 cubed. And again, as far as you want to go with that, you can with this formula. So if you were going from 1 to 99, then you would plug in 99 for n. If you were going from 1 to 75, you would just plug in 75 for n. And that's how that can work. So some very, very useful formulas that will, as far as you're concerned right now, at the very least, give you an opportunity to get some bonus points. All right, so pause the video if you still need to write that down, but here we go. Let's finish with these examples and call it a day, or call it a video. So once you do this, so quick reminder, what have we done in this example so far? We've just applied the properties, breaking it up into separate sigmas, and then bringing out, whatever coefficients that there might be. There was no coefficient here. Again, we could have brought the 9 out and just left it as 1, but whatever. But here's the next step. We do those properties so that we can isolate, sigma I cubed, sigma I squared, sigma I, and this is, you could call this sigma C, or sigma 1 if you brought the 9 out in front. And those are formulas, okay? So that's like the next step. Sigma I cubed, this is the formula for sigma I cubed. This 2 gets brought down, but then the sigma I squared, it's that formula, right? Right here, sigma I squared. N times n plus 1 times 2n plus 1. And then right here, this, like the 4 gets brought down, but just that sigma I part, there's the formula. And then, sigma 9, like a sigma C, is just 9n. Now, the last couple of steps, or the last step, whatever, it's like, well, we're in this problem, we're going from 1 to 76. So all you have to do now is, I know it's a little bit, arduous or whatever the word is, but you just have to do this whole deal where n is 76. So this would be, so you're probably going to want to go to your calculator to do 76 squared, 76 squared times, that would be like 77 squared divided by 4, and you should be getting that. And then, did I leave a 2 here? Nope, I guess I included the 2. So you would be doing like 76 times 77 times 2 times 76 plus 1, all divided by 6, but then you'd also have to multiply by that 2 to get that number. And then this would be 76 times 77 divided by 2, and then times 4 to get that number, and then 9 times 76 is 684. So you just have to very carefully crunch those numbers with, plugging in 76 for all the n's. And then I'll save you the trouble of, unless you're faster than me right now, or pretty fast, when you add all those up, or add, subtract, whatever, when you do the final cleanup, 8,847,540. So that's the basic routine to apply these formulas. So again, that was because we can't use one of the formulas we saw in 5.2 or 5.3 because that is not arithmetic and that is not geometric. But we are able to isolate the I cubes and the I squareds and the I and the constant so that we can apply these other awesome, amazing, tremendous formulas. All right, so there's a couple examples that, what you really should do is pause the video and try these on your own or one at a time, and then, start the video back up again to see if you were correct. But so pause the video because I'm going to run through this in like 2 seconds. So last chance to pause. All right, ideally you've attempted this, and the first step was to, well, I guess I combined a couple of steps. I broke it up into separate sigmas, and I also brought out the 3 in front, the 5 in front, and so then at that point you're able to, call upon the formulas You know, sigma I squared, that formula, sigma I, that formula, and then sigma some constant like sigma 2 is 2n. Or again, like, you know, you could technically bring out the 2 and say that it's sigma 1, which is just the n. Whatever, either way. And then once you apply the formulas, now what are we going to be plugging in for n? 99. So after very carefully plugging in 99 for all the n's and, you know, relying on your calculator, we have, you know, maybe this is sort of like your next step that you wrote out. I don't know how much you actually wrote out, but the final answer you should have got is, what is that, 1 million? 1,009,602. So again, I'll in case you need it, I'll give you like another quick chance to pause the video, because you should attempt this last example on your own before just seeing what the correct answer is. So 3, 2, 1. So again, apply the properties, break it up, separate sigmas, bring out the coefficients, apply the formulas. Here we're just doing sigma cubed, that formula for sigma I cubed, this formula for sigma I, and then sigma 1 is just n, you know. So speaking of n, here we're going from 1 to 60. So this would be like 60 squared times 61 squared, all divided by 4. And again, I don't know how much you broke this down and how much you wrote out in baby steps, but, you know, before multiplying by 2, I guess you got 3,348,900. When you plug in 60 here, 60 times 61, all divided by 2, boom, bam, and then of course n is just 60. And then the final answer you should have been able to get on your own is 6,683,220. So there it is. Like, and again, at this point in time, you know, in the year 2022, 2023 school year, right now, this is basically so you can cash in on an opportunity for bonus points using these cool formulas. And no worries, you will, at least again, that's my routine in the current days, is to give you these formulas on the formula sheet for you to use. So I guess that's it. So video over.